All right, so now we get to move on to graphing linear inequalities, okay? So I know people are like, oh my gosh, you just made us solve for a variable, now you're gonna make us graph? Yes, I am. All right, so graphing them is exactly with a few twists, like graphing lines, okay? Remember, we graphed this whole y equals mx plus b thing, and we had a slope, remember? So we have a slope and our y-intercept where it crosses the the y-axis. Okay, remember our slope is still rise over run. Okay, now this box right here, that's where the inequality is going to go. Okay, so instead of y, oops, sorry guys, instead of y equals, we're going to have y is less than, and then something over here. Okay, now there are two, actually technically I guess four new things. Okay, the first thing is when we graph inequalities, sometimes we'll have solid lines and sometimes we'll have dashed or dotted lines. So a solid line is automatically, if we have a greater than and equal to or less than or equal to, automatically I see those two and I'm going to know, oh, my line is solid. Okay, or it could look like this. Doesn't matter. Okay, it's going to be solid either way if we have those two signs automatically. Same with dotted or dashed lines. So if solid lines are the equal to's, that means the dashed lines are going to be greater than or less than. And I'm literally, we're talking dashed lines. Okay, so automatically I see these two symbols, my line's dashed. Boom, done. Okay, if I see these two symbols, automatically my line is solid. No questions asked. Done. Okay, so those are two things that we can figure out right off the bat before we even start graphing our inequalities. Okay. The second thing we kind of have to wait on. Sometimes it'll be very obvious, and other times it'll be we have to solve a little bit first. Okay, and we'll get there. But it's shading. Okay, we get to shade above the line or below the line. Okay, so when we shade above the line, we're looking for a symbol that's going to be greater than or equal to. Okay, so if we shade below the line, that's going to be less than or equal to. So let me grab two highlighters because I want to show you what that looks like. Okay, so I'm going to draw a couple of different examples of just random lines and what it looks like to shade above. So I'm going to shade that in green, and shade below will be in pink. Okay, so if I have a line with a positive slope, let's just do this. If I shade above the line, it's going to be on this side, which means below the line is this side. Okay, so if I have a line with a negative slope that goes like this, above the line is on this side. Below the line is on this side. Okay? Pretty explanatory, I think, but I'm not going to lie to you. A lot of people actually get, with the negative slope, they get the shading a little confused. Okay? So I want to make sure that you have that before we start graphing things. Okay? We also have vertical and horizontal lines. Okay, so a vertical line looks like this. If I'm shading above a vertical line, I know it doesn't make sense, but it's going to be on this side. If I shade below, it's going to be on that side. Actually, hold that thought. I think I'm having a brain fart. I'm going to pause the recording. I'm going to look it up, and I will come back and either let you know if I'm right or let you know if I'm wrong. Okay, I'm back. I was wrong. Okay, that is my fault. I was wrong. These colors should be switched. Okay, so really, I don't have white out. Okay, but switch these. Okay, so this is above, and this is below. Okay, that's my fault. Okay, brain farts are really serious after Thanksgiving break, I guess. My fault. Okay, horizontal lines. I'm gonna go along with the horizon. Okay, above and below. All right. I'm so sorry, guys. Okay, inequalities, they have these things called solutions. Okay, these solutions can be found either in the shaded part, so in the shaded region, I think I spelled that right. Okay, in the shaded region or along the solid line. Okay, so a solution can be found on a solid line, not a dotted line. No dots. If it's a dotted line, no solution is on that line. It can't be. It might look like it, but it is not. It cannot be. Okay, so I have a couple of examples for you. I believe I put graphs on your notes. Okay, so I'm going to go through it. I'm going to graph these with you. I don't know what to do with my... Okay, so we have y is greater than or equal to negative 3x plus 4. Honestly, this is my slope. Let's use colors. Okay. My slope is negative 3, which is the same thing as negative 3 over 1 because we have rise over run. This is my y-intercept. And I can tell all of that just by looking. This tells me that I have a solid line. Okay, so I'm going to go ahead and plot some of these points. Where's my marker? Here we go. All right, so I know that we go through 4, and my slope is negative 3 over 1, negative 1, 2, 3 over 1. And I'm going to go ahead and can I connect these dots? Yes, I can. And the reason why is because I'm not trying to get y by itself. So I'm not dividing anything. I already have it solved for my variable. So I'm going to go ahead and give myself my solid line. Okay. Shading. This is greater than. All right. So that means I have to shade above the line. So I'm going to go ahead and do highlight it in green. So if I'm shading above the line, looking at my notes, there we go. Okay. So looking at my second example, we have less than or equal to. So this is a solid line because of that equal to sign. This is my slope, 4 over 3. So rise up 4, right 3. And then my y-intercept is at negative 4. So let's go ahead and plot that. Negative 4. So up 4, right 3. 1, 2, 3, 4. 1, 2, 3. It's a solid line. Okay, so now am I shading above or below? Well, it's less than, so I'm shading below. So on that side of the line. Okay. All right, we haven't really looked at these, but x is less than or equal to 1. Stark, there's no slope, there's no y equals, there's no y anything. What do I do? It's because this type of an equation is the equation of a vertical line. Okay. Okay. So it's a vertical line that goes through -1. Okay, so that right there tells me exactly where I go through. So I don't even think I can draw a straight line just by boom. Okay, and I know it's solid because it's less than or equal to. Because it's less than or equal to, we're shading below. Now remember, this was the typo on your notes, so I'm sorry, or the shading error on my part. Because it's below, we're going to shade this side. Okay. So if x inequality is a vertical line, that means y inequality is probably a horizontal line. Ooh, we got some fun things going on here. Okay. Notice it says greater than. Not greater than or equal to. That says greater than, which means it's not a solid line. It's a dotted line. And, excuse me, it's a dotted line through -4. Okay, so I'm going to find -4 on the y-axis because it's a horizontal. So I'm going to find on the y-axis -4. I'm just going to go ahead and draw some dash marks there. Okay, so because it's greater than, I'm shading above. So that means I'm going to shade on this side. Okay, that's graphing inequalities. Again, I'm sorry for that, that mistake. That's my fault. If you have any questions, let me know, but your practice problems and stuff will all be on Canvas.